Hi, little Wildcats. I'd like to show you another science demonstration from this book of 50 science things to make and do. But before I get to this, I want to tell you something about it, okay? What we're going to be doing is called optical illusions. For example, when you look at this piece of paper, what do you see? Do you see a vase or do you see faces? Maybe you see both. Sometimes it's hard for our eyes to separate out exactly what we see on the paper. So I'll show you what I'm talking about, okay? This piece of paper has a black figure on it, and the black figure is really a vase. If you can focus on it, it's exactly the same as this. This is the vase. If I put a flower behind it, maybe you can tell even more. It's a vase, you can put a flower in. But when you stop looking at the black part and you just look at the white part, you may be able to see some faces. I'll take away the flower. Try to look just at the white part. Do you see the side of a person's face, a profile like this? This is my profile. This is this person's profile. You can see it better if I show you the person's face sideways. I actually, oops, I drew it on this side. I drew a little eye on it so you can see the sideways face. So anyway, that's how your eyes can kind of play tricks on you. Do you see the vase or the faces, or can you see both? There's another kind of optical illusion. This one is kind of tricky. See these three lines? They're three lines, and some of them have arrows pointing this way, and some of them have an arrow pointing in. They all look different, don't they? If you were to look at it, which do you think is the longer line? And what I'm talking about is not which extends further, but the line, this line, from this point to this point, and then underneath it, this point to this point. Which looks longer? Would it surprise you to know that they're all the same length? I'll turn the page over and you can see. There's a straight line drawn down to each point on the line before we count the arrows at all. So you can see that from here to here, and here to here, and here to here are all the same length. And you can double check it by taking a ruler or a measuring tape and putting it at the end to end. It's almost 6 inches for each of those straight lines, not counting the arrow part. They're all the same length, but when you look at them like this, your eye gets tricked because of this part. It gets tricked into thinking the lines themselves, not counting the arrow part, are actually different lengths, but they're not. The last one I wanted to show you is this piece of paper. So what do you see first on this? Do you guys see any legs on here? It's kind of funny. There's a whole row of legs. There's a bunch of men's legs and a bunch of ladies' legs. The men's legs are wearing like a man's shoe, like a loafer, and the ladies' legs are wearing a high heel shoe. If you look at it like this, maybe you'll get a better idea. I put my hand there. Can you see ladies' legs with high heel shoes on them? You can count them. 1, 2, whoops, half of one. 1, 2, 3, 4, 5. But then if I turn it around and you don't focus on the ladies' shoes up top, can you see the men's loafers? 1, 2, 3, 4, 5, 6. But sometimes it's hard when you just see the whole sheet of paper to separate out whose legs are where. Okay, so that's an optical illusion, and there's a little project we can do from this book. It's called Catch the Birdie. And what you do, I'm going to send to Mrs. Orr some templates you can use, some examples you can use and cut out at home. But what I did was I took a mug and put it upside down on a piece of thick paper and I traced it with a pencil 2 times, and then I cut out the circles. And on the circles, I drew 2 different things. On the first circle, I drew a bird. And then on the second circle, I drew a bird cage. I don't know if you guys can see that, but it's like an old-fashioned wire bird cage. And then I took the 2 pieces of paper and I cut holes, 2 holes in each side, and then I put them together so it looked like this. The bird is upside down and the cage is right side up. And then I tied them together with string. I punched 2 holes in each side and I tied them together with string, just like it said to do in the book. And what I'm gonna do now, hopefully it'll come out so you can see it. What I'm gonna do now is I'm gonna take the string that I wound through. I got some yarn and I wound it through and tied it. And I'm gonna spin it so that the string gets all wound up, okay? And then when I unspin it, I want you to take a close look at the bird and the bird cage and see if you can see the bird separate from the bird cage, or if you only see them together in your mind. Okay, so I'm gonna wind them up. Ready? Hope this works. Okay, wind, 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 wind. And as I'm doing this with my hands, the string is getting all twisted, 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 so that in a second, hopefully it will work. I'll be able to stop and start to untwist it. It looks like it doesn't want to twist anymore, so here we go. My cameraman can get a good picture of this. Maybe we can look at it. We can focus in on the bird as it unwinds. Ready? Do you guys see the bird separate from the bird cage, or did you see them together? According to the book, and from the example I looked at before, you're supposed to see them together, because your mind, when this is spinning so fast, is supposed to see the bird and the bird cage together and not be able to tell that they're really 2 separate pictures. So I hope you guys like that experiment in optical illusions. I hope you can tell, and you can try it at home. It's not really too hard. You just need to get a little bit of paper and you can draw your own cool bird and try it. Okay? Thanks for listening, guys. See you later.